Okay, this is a end of unit topic test for IGCSE, forces in motion, um, and my students did it a couple of weeks ago, and I just want to put it on YouTube for students who may have missed the feedback session, and it will be useful for anyone revising for mock exams in year 11 as well. Okay, so first question is about forces. It says a car accelerates along a level road. I've highlighted level road because they're putting that there to tell you that there are no other forces involved. If it's a level road, things like being downhill won't affect like an extra force, like due to an aspect of gravity coming into it. So the diagram shows some of the horizontal forces acting on the car as it accelerates. So they're telling you it's accelerating, and you should be able to work that out because the driving force, the arrow forwards, is longer than the arrow backwards. So if the arrow forwards is the force forwards is greater than the force backwards, then it will accelerate. Okay, so the car's accelerating. They told us that, and it says the driving force acts on the car, as shown in the diagram. State the name of the other force shown in the diagram. Well, that's air resistance or drag to get the mark. Okay, then they want you to, now that you know that it's accelerating, they want you to state the formula linking the unbalanced force. In other words, driving force minus the air resistance will be the unbalanced force. That unbalanced force is equal to mass times acceleration, which is Newton's second law. Okay, when there's an unbalanced force, the object will accelerate, and the acceleration will be in the direction of the unbalanced part of the force. They've given you the force, so I show you how I highlight in the exam the key points, and I'm actually writing F equals 2,900, and the mass of the car, I'm writing M equals 1,200 kilograms. Okay, so now all I have to do is to use the triangle method to work out that acceleration is force over mass. Divide one by the other, you get 2.42 if you do it to three significant figures. But you'll notice that the data that's been provided for the force and the mass are both only accurate to two significant figures, so you really only need to quote it to 2.4, two significant figures, and the units are meters per second squared, which they provided. So the 2 marks are substitution and correct answer. They probably won't penalize you for putting three significant figures, but that's how you decide how many significant figures to use. It then says the driver sees an obstacle in the road and applies the brakes. The driver has a reaction time of 0.5 seconds. He applies the brakes for 2.5 seconds. The graph shows how the velocity of the car changes when the driver sees the obstacle, from when the driver sees the obstacle until the car stops. So we have to go to the next page to see the graph, the way the paper has been printed. So the thinking distance is when the reaction time is, and then the braking distance is when after the 0.5 seconds and the brakes have been activated. Okay, so the first part of the graph from 0 to 0.5 seconds, the rectangular underneath the U, yes, which is the initial velocity of 18 meters per second according to the scale drawn, is the thinking distance, and the pink area is the braking distance, which I've highlighted because they're going to focus on that. So it then says describe how the thinking distance is affected by the conditions of the car's brakes, yeah, and the speed of the car. Well, the condition of the brakes have no effect at all on the thinking distance, because the thinking distance is only controlled by your time to react. Yeah, you haven't even activated the brakes yet, so the condition of the brakes has no impact on the thinking distance. So you need to make sure you read really carefully when you're doing these questions. So for example, here the key terms that you need to use are thinking distance. Yeah, so be careful when you're reading that you're highlighting the bits that you need to be aware of. Then the speed of the car, obviously the speed of the car in this case, yeah, is 18 meters per second. If it was going faster, the area under that graph, which is distance, if you remember the area under a velocity time graph is the distance traveled, the higher that speed, the greater the distance traveled. So the thinking distance will be greater the faster the car is traveling. Okay, so I hope that makes sense to you. Use the graph to calculate the braking distance. The braking distance is the pink area. I've highlighted in pink. So braking distance is the area of a triangle. So the area under the graph is how you worked out, and if you know area of a triangle is half the base times the height, so you just got to multiply the height by the base and then divide it by 2, and you'll see my maths is showing to 3 significant figures. You will get 22.5 meters per second. Now remember, you need to only do the part of the triangle, so you don't need the bit before 0.5 seconds. So time taken from 3 to 0.5 seconds is 2.5. The height of the graph maximum height was 18 meters per second, so you do 18 times 2.5 seconds, divide that by 2, and if you do 2 significant figures you can round up to 23 meters per second, because once again the data is only accurate to 2 significant figures, because that's the data that's been provided from the previous question. Remember, it's only really known to 2 significant figures, including on the time axis. You'll notice the times are given as 0.5, 1.0, 1.5, so really maximum accuracy in this question is 2 significant figures. Question 2 is about a speed camera positioned at the side of the road. It tells you the camera measures the speed of the vehicle on the road to determine whether the vehicle is traveling too fast or not. The camera takes 2 photographs, it says, of the vehicle exactly 0.25 seconds apart. So time taken, we know, is 0.25 seconds. The photographs are then used to measure the distance traveled by the vehicle, during the 0.25 seconds. So that will give us the distance. State the formula linking average speed, distance, and time. Well, average speed is the total distance traveled divided by the time taken. Okay, so in the time between the 2 photographs, the car travels a distance of 6.5 meters, they say. So we know the distance traveled S is 6.5 meters. We know the time taken between the 2 photographs is 0.25 seconds. They just want you to divide one by the other and you'll get 26 meters per second, 2 significant figures. Okay. It then says the speed limit of the road is 80 kilometers per hour. Yeah, well, we've just calculated in meters per second. So you need to change these units, and that's just maths, into meters per second, which is what I've done. 80 kilometers is 80,000 meters. 1 hour is 3,600 seconds. So all I've got to do is to divide 80,000 by 3,600, and because that's converted the kilometers into meters and the hour into seconds, so the answer will be 22.2 meters per second is the equivalent of 80 kilometers per hour. Okay, one of my students asked me, how do you change it? I said, that's just maths. So you do need to be able to change units based on things that you've done before in maths or in science. Okay, so to 3 significant figures is 22.2 meters per second. We probably don't know it that accurately, but so it's about 22 meters per second. So the car is exceeding the speed limit, because the speed we worked out in the part before was 26 meters per second, which is greater than the 80 kilometers per hour speed limit, which would be the equivalent of 22 approximately meters per second. I kept it as 3 significant figures just to make sure. Okay. You could do it the other way and work out what 26 meters per second is in kilometers per hour. I think it's more confusing that way, but some students could have done it that way, and if they converted it correctly, they'll get 26 meters per second in kilometers per hour would be 93.6 kilometers per hour. Okay, and again, you just have to do the same comparison and say the car is still going faster than the speed limit. Okay, as 93.6 kilometers per hour is greater than 80 kilometers per hour. Okay, now this is the velocity of a lorry. Yeah. Oh, part B, it says the velocity time graph shows how the velocity of a lorry changes with time. So it goes from initial speed of 5 meters per second, I've drawn it on the y-axis, to a velocity of 24 meters per second, reading off the scales that they've given us. Nice, easy scale that they've chosen. Time taken is 60 seconds. Explain how the graph shows that the lorry has a constant acceleration. Well, the acceleration is the steepness of a velocity time graph, which is the gradient. Yeah. So if you know that, you get 1 mark. And since the gradient is constant, yeah, it's not curving, it's a constant steepness. So it means the acceleration must be constant. And then say the formula linking acceleration to change in velocity. Well, acceleration is change in velocity divided by time taken. You should always write these answers out as full word equations, yeah, because they can't be sure if you put some symbols in that you know what the symbols mean. So the standard way in physics is to write definitions or equations in as word equations. I then put it as a symbol equation as well, which would be v minus u over t. You need to remember that u is initial velocity in the standard form that's used in GCSE and beyond, and v is always the final velocity. Okay, so a equals v minus u over t. If you look at the graph I did, I put the v is 24, u was 5, so 24 minus 5 in the time taken, which again is 60 seconds on the graph. 24 minus 5 divided by 60 gives you 0.317 to 3 significant figures. They're giving you the units, so you don't need to put them in. And if you round it up to 2 significant figures, which is most of this question, you will get 0.32 meters per second squared. Okay, that's the 11 marks for this question. Okay, so if you're my students, you need to make sure that you've made all your corrections and in the correct color, so we can see where you've improved after the feedback. Question 3, it says a car driver sees a hazard on the road ahead. Yeah, the graph shows the velocity of the car when the driver sees the hazard. So it's another question on thinking distance and braking distance. So you've got the thinking section first and the braking section afterwards. The triangle is the braking, the rectangle is the thinking distance. Okay, so the initial velocity is 15 meters per second and he was thinking for 0.9 seconds. That attention to detail is shown. If you don't work out that it's halfway between 2 squares would be 0.9, you will lose that mark. Okay, so attention to detail is what gets you the mark. In fact, I always tell my students 3 things you need to get all the marks: detail, depth, and clarity. Okay, so then you need to work out the total stopping distance. Well, stopping distance is the distance traveled while reacting or before reacting. So that's the thinking distance. So it's the area of a rectangle of height 15 and time would be 0.9. That gives you 13.5. If you get that right, you get 1 mark. If you do the area underneath the braking distance, which is a triangle, it would be 3.1 seconds of braking. Yes, so you need to work out that's 3.1 because it started at 0.9 and finishes at 4.0. And then what you do, if you work it out properly, remember you have to divide by 2 because it's a triangle. It'll be 15, the initial velocity, times 3.1 seconds. Divide the answer by 2, get 23.25. That's the second answer. And then if you add them together, you get 36.75. Round it up to 2 significant figures, and you'll get 37 meters. Oh, it's 1 mark probably for knowing that the thinking distance is the total stopping distance is both areas, thinking distance and braking distance, the area under the graph. Okay, so knowing what you're doing is 1 mark, and then doing it properly is the rest of the marks, and you'll get 4 marks. It then says calculate the acceleration of the car when it is braking. What if it's braking, it's decelerating, so the answer should become negative because the final velocity is 0. Yeah, the initial velocity was 15, so you should really put it the right way around. 0 minus 15 divided by the time it took to brake, 3.1 seconds. Divide the 15 by the 3.1, you get 4.8, and don't forget the negative sign if you want to get the full marks. Hope that makes sense. That's a deceleration of 4.8 meters per second, but they've asked you to calculate the acceleration, so you should give it as a negative vector quantity. The next question, it says the speed of the car obviously affects the thinking distance and the braking distance. Discuss other factors. Yeah, so they mean not speed. That affects the thinking distance and braking distance of the car. So the way the mark scheme is designed is that you get 2 marks for the thinking part, which is this, and 2 marks for the braking distance. So braking distance and thinking distance. So now clarity is how you're going to lay your answer out, because it says discuss, so they don't want just a list. Okay, and I think this is a bit confusing, this question. So I've put 2 factors linked to increasing thinking distance. You see I've highlighted increasing because shouldn't just say that they affect a thinking distance. You should say in what way will they affect it. Well, tiredness will increase the reaction time, so it increases the thinking distance. That's what I mean by detail, clarity. Be really clear that you show the examiner that you really do understand which way they're going to affect it, just to make sure you get it. They'll probably give you 2 marks from the list under the top: tiredness, age, consumption of drugs or alcohol, and being distracted. Those could be any of those 2. And if you put more than 2, they probably only take the first 2. And I think that's the way the mark scheme is set up, to give you 2 factors for increasing thinking distance and 2 marks for discussing factors that affect the braking distance. If you only do half of them, you're not going to get the full marks. So you can't just put 4 for thinking distance. You need to discuss both factors, thinking and braking. So I put mass of the car, and then I've made a mistake, so I need to cross out speed of the car, because they say what? Yeah, so speed of the car is already mentioned in the question, and the question says discuss other factors. Okay, that was my mistake when I was writing out my answer. So the poor condition of the brakes will increase braking distance. A greater mass will increase braking distance. So I should have put here greater mass. Yeah, poor condition of tires. So don't just put condition of tires. Put poor condition of tires, poor condition of brakes, poor condition of the road surface. Example, if it's wet or icy, these were things that will increase braking distance. So make sure you have 100% clarity. Show the examiner you know what you're talking about. Question 4 is about a hailstone. Oh, you could have put going downhill in the last question as well. That could affect the braking distance. Okay. Hailstones are small balls of ice, it says. Hailstones form in clouds and fall to the ground. Okay. So figure 1 shows what a hailstone is. That'd be helpful, having a diagram. If English is not your first language, you may not know what a hailstone is. Okay, so a lump of ice that falls from the clouds. A hailstone falls from a cloud and accelerates. Why does a hailstone accelerate? What is Newton's second law? If something is accelerating, it means there must be an unbalanced force acting on it. Okay, another word for unbalanced force is resultant force. Okay, so the resultant force must be downwards for it to accelerate. Yes, and that's because the weight acting downwards is greater than the air resistance. Yeah, unless it reaches terminal velocity. Yeah, but it doesn't. And when it first starts falling, there is no air resistance, because the air resistance is determined by the velocity. If there's no speed initially, it will be only weight pulling it down, and then gradually the air resistance will increase until they become equal, the weight and the air resistance, and then eventually it will stop accelerating if it's had enough distance to fall. This is the next part of the question. The hailstone stops accelerating and reaches terminal velocity. So that's when it stops accelerating. Explain why the hailstone reaches terminal velocity. Well, to go terminal velocity means the forces must now be balanced forces. So terminal velocity means constant velocity, and that's Newton's first law. Whereas before, when it accelerates, it's Newton's second law. Newton's second law is about unbalanced forces. So I've written, as the hailstone accelerates or speeds up, the air resistance increases, yeah, gradually. Eventually, at a certain speed, yeah, the air resistance will balance or become equal to the weight, yeah, and at this point, there is no result force. So that's how you get your 3 marks, the 3 bullet points I've put. Hope that makes sense. Okay. I'm scribbling on the screen in yellow. The scientists investigated how the mass of a sail of the hailstone affects the terminal velocity. Yeah, so they've given you a graph. So as the mass increases, the terminal velocity increases as a curve. Okay, and they've only drawn it from 5 up to 20. Okay, it says why does terminal velocity increase with mass? So they want you to explain why, and they're giving you a choice. So the first one says as mass increases, the cross-sectional surface area of the hailstone increases. Yeah, well, if that happens, then there'll be more air resistance. I'm not sure that's the correct answer. Yeah, because if it has a greater surface area, it will create more drag, because the area is what affects the drag, or one of the factors that affects the drag force. And then it says as mass increases, the volume of a hailstone increases. We know that, but I'm not sure that's relevant, because all masses accelerate at the same rate, more or less. That doesn't explain why it reaches terminal velocity, or why the terminal velocity increases with mass. So what you should say is, as the mass increases, the weight of the hailstone increases, so it will take longer for the air resistance to be able to equal that weight. So therefore it's going to have to go faster for the air resistance to become equal to the larger weight for a larger mass hailstone. Okay, greater weight equals greater time for the drag to be able to reach equilibrium with the weight. Okay, that's how I've explained it further. Part D then says explain the difference in the maximum kinetic energy of a hailstone with a mass of 10 grams and a hailstone with a mass of 20 grams. So you have to use the graph. So 10 grams and 20 grams, I've drawn them on my graph. 10 grams is 4 meters per second. Yeah, so that's over here. I've drawn it on my graph. I've shown the arrows. So again, I've got clarity there. And then for the 20 grams, you'll see the arrow upwards will equate to going across to 32 meters per second. So these are useful ways of showing that you've done some thinking and some working out on the graph. So one's 4 meters per second, one's 32 meters per second. What does the question say? Explain the difference in the maximum kinetic energy of a hailstone of 10 hailstone with a mass of 10 grams and a hailstone of 20 grams. Well, kinetic energy is half mv squared, so it depends on the mass and the velocity. As mass increases on the graph, so does the terminal velocity. That's what I showed you from, and then again you then show that you know that the difference is from 4 to 32, so therefore you could say, you could actually work it out. But I think you can do it without working it out. So as long as you've explained that you know what kinetic energy is, and you've used the graph to show the difference in the speeds, then you've got everything that you need to be able to clearly explain in depth and detail and clarity why the larger mass has a greater kinetic energy. Okay, it has larger mass and a larger velocity, so obviously it must have a greater kinetic energy. Part E then says the kinetic energy of a hailstone is measured in joules. Yes. So kinetic energy is the movement energy, and it's half mv squared. Yeah. Now some students may not have done this, so when we marked it, we actually took away the kinetic energy questions from the total mark. But it's good revision for those of you near 11. So the kinetic energy of a hailstone is measured in joules. Which of the following is the same as 1 joule? And the answer is the first one. A Newton times a meter is work done. Yeah. And work done is the mechanical energy transfer when you do some physical work. The force times distance gives you the answer in joules. So again, this question perhaps is more to do with energy than forces. Okay. So it depends whether your teacher has taught you this during the force of motion topic. But anyway, there's a bit of pre-learning for you if you're going to do energy later on. Energy comes in Unit 4 in the Edexcel IGCSE. Okay, figure 2 is repeated below, the one that we looked at before where I showed you the different velocities for the 10 grams and 20 gram masses. and then it says a hailstone hits the ground at its terminal velocity of 25 meters per second. So I've looked at that on the graph. This time I've gone from the terminal velocity side and then taken the arrow to go and see what the mass would be, and I've made it approximately 18.5 grams. Okay. And it says a hailstone hit the ground with that terminal velocity. Yeah. And the hailstone took 0.060 seconds to stop moving. So we know from the graph that it was 25 meters per second. They told us, and they want us to determine the average force. So if we know the change of velocity when it hit the ground, obviously when it hit the ground it splattered. Yeah, so immediately well, not immediately, it took 0.06 seconds to stop. So we know the change of velocity and the time it took to change that velocity. We know the rate of deceleration is 25 divided by 0.0. So we know that approximately the deceleration was 417 meters per second. Yeah, squared. And therefore, if we want to know the force involved to create that deceleration when it hits the ground, you multiply F equals ma to do the second part. So there's two bits to this question, F equals ma and being able to work out the deceleration. Yes, I should have probably put it as a negative, but I didn't. Okay, because they just want you to know the average force involved, and obviously the force will be against the motion. So you could even put the answer as a negative. To three significant figures, I put 7.71 using my values as shown, using the accurate values, but probably you only need to know it to two significant figures. Next question, question 5. A toy horse that below shows a child on a playground toy. The springs at the bottom look quite sturdy and strong. The springs have been elastically deformed. What does it mean? What is meant by elastically deformed? Well, if it's elastically deformed, it's still elastic. It will return to its original shape or length. It means it's not permanently deformed. If it was beyond the elastic extension, the elastic limit, it would then be permanently deformed, and we call that plastic deformation. Okay, so it will return to its original shape or length when the force is removed, and you do need to add that clarity of saying when the force is removed, yeah, to get the 2 marks. Okay, depth, detail, clarity. Once again, a student investigates the relationship between the force applied to the spring and the extension of the spring, and that's been plotted in this graph here. Yeah, so force on the y-axis, extension in meters on the x-axis, and then they want you to describe the method that the student could use to obtain the results given in this graph. Yeah, figure 2. So you should include a risk assessment for one hazard in the investigation. In other words, this is scientific skills. Do you know how to do this experiment, and can you describe it in depth, detail, with clarity? Your answer may include a diagram. So I haven't written this answer out at all. So they're giving you all that room to write the method out. Yeah. And if you go to the answer, you will see this is the mark scheme. So at the end of the paper, you can look at the mark scheme. Okay. So we're looking for question 5, I think. So it will return to its original shape. Now here is the method. So level 3 method would lead to the production of a valid outcome. So if you've got everything right in your method, you'll get a valid outcome. In other words, you'll get the graph that they've done. The key steps are identified and logically sequenced. Well, that's what we want. Level 2 means you haven't quite got everything right, so you'll get 3 or 4 marks. And level 1 would just be getting 1 or 2 marks. You've missed quite a few bits out in terms of depth, detail, and clarity. And here's some content that would allow you to get one of those levels of answers. So the examiner will look at the quality of your answer, and they'll be looking for these things. So set up a clamp with a stand, and that should be in your diagram. Hang the spring from the clamp. Yeah. Use the second clamp and the boss to fix a 1/2 meter rule. Yes. or it doesn't have to be, it could just be a meter rule alongside the spring, so you keep the meter rule at the side so you can easily see when the spring is extending relative to the starting position. Record the ruler reading that is level with the bottom of the spring. So when you've drawn your diagram, you really want to have the spring, so this is, say that's the spring, you want to measure to the bottom of the spring there, okay, because it's going to stretch from here to here. That's going to be the extended length of the spring, okay. So sorry, it's a very bad diagram. I'm actually using my finger as a pen right now. I don't have an Apple pen with me, okay. So then you hang the masses on here, yeah. So you could hang it says a 1 Newton mass or a known weight from the bottom of the spring. Record the new position, so as it goes down and you got, say you got the ruler to the side and the ruler's fixed, you can just read off where it is on the ruler and just write the meter ruler reading, and then you could work out the difference from the starting position to calculate, yeah. Here it says calculate the extension, because the extension is a calculation. It's the starting position, the finishing position minus the initial position, okay, because you want the total extension, okay. So I wouldn't have put measure the extension, I would have put calculate the extension from the change in position of the bottom of the spring. And then of course for the experiment to be fully valid, you need to keep adding weights and to repeat this process for at least 5 data points to get a good graph. Okay, minimum for a straight line graph at GCSE level would be 5 data points. For each new force, yeah, you record the new position of the bottom of the spring, and therefore you would need to calculate the extension as a consequence. So don't say measure, yeah, say calculate. Okay, what does calculate mean? It means the final position of the spring compared to the initial position of the spring before you've added any weights. And then the risk part, they want you to show that you're aware of safety in these experiments. So they're giving you hazard, the clamp might fall off the desk. Risk would be injury to your feet, yeah. Precaution, use a clamp to fix the apparatus to the bench, and so on. Ensure the slotted masses hang over the base or foot of the stand. Ensure the boss is screwed tightly into the stand and clamp, or put heavy masses on the base of the stand to keep it stable. Yeah, so you can move out the way. So the hazard would be this. Another hazard could be that the spring could break, come loose. Risks is eye damage, so wear safety goggles. So as long as you got a sensible answer for your risk, that you've thought about safety, that's what they're after. Okay. It says if a risk is not given, the answer can still reach level 3, but you'll lose 1 mark because you didn't think about the risk and they've told you. Okay. So once you've done all that, going back to the question, they want you to do some analysis. So that 6 marks is where you put the method here. Always use the space given for a diagram, and your first thing would be set up the apparatus shown in my diagram and make sure your diagram is neat and labeled. Okay, and you'll see that it'll be easier for you to describe your 6 marks for your method then. Which equation links force extension E to force F and spring constant K? Now I think in Edexcel they actually use X for extension, but some exam boards use E, and this test has been put together, and I think this is a AQA question. Okay, so it's not from the Edexcel paper. So which equation is correct? The answer is force equals spring constant K times extension. Okay, so it's the second one. That's just something you need to know. That's all 1 marker, seeing that you know the equation. It then says work out the spring constant. Well, if the equation is known, F equals Kx, the steepness of this graph will be the spring constant because it's force divided by extension. So I've shown you from the top, yeah. I've shown my values on the on the graph. There's my change in force from 5 to 0, yeah, and then the extension is from 12.5 centimeters or 0.125 meters, yeah, to 0 here. So we know those values. So show your figures on your graph. Again, clarity, depth, detail is what gets you the marks. You divide the 5, which is the ups, yeah, the delta y, the change in the y part of the graph, divided by the change across the x-axis, and it will give you 40 newtons per meter to two significant figures. Okay. All right, so that's how you get the 3 marks. Show your data, put the numbers in correctly, get the answer out with the units which are given to you. Okay, and then the student concluded, it says the extension of the spring is directly proportional to the force applied to the spring. Describe how figure 2 supports the student's conclusion. Well, it's a straight line and it goes through the origin. That's what directly proportional means. Okay, straight line going through the origin is what directly proportional means, because if you double the force, the extension will double. If you triple the force, the extension will triple. That's what directly proportional means, and you do need to know what directly proportional means. Now I'm going to go through the mark scheme. I'm going to stop it for each question. So question 1, you can then go back and check where you got the marks or where you drop marks to do your corrections if you want to just use the mark scheme. Okay, and tells you within the notes column additional information. Remember that the mark scheme is written for teachers, so if you don't understand it, you'll have to ask your teacher. Okay, part B of question 1. So that's not, the first question was 9 marks in total. It shows you how to do whatever I showed you already in my written out answers. Question 2, yeah. So you pause the video, go through it, just to double check that you've understood how to get the marks. Okay. And question 3 is the one where the braking distance, area under the line that you need to work out, both the thinking and the braking distance, shows you how you get your marks. Okay, again, you'll see that they are giving the answer to 2 significant figures, but they will allow GCSE students to show additional number of decimal places. But to be a good physicist, you need to make sure that you understand why you shouldn't put too many values. Okay, there was a negative acceleration 4.8, so you can stop it, and you see how they're marking the bit about the factors that affect the thinking distance. 2 marks for that, and 2 marks for factors affecting the braking distance. Question 4, can't remember what that question was about. Hailstone, I think. Yes, it's the hailstone question. So that's how you get the marks. Okay. Part E and F to follow. So again, they've got guidance notes for teachers to make sure they're marking accurately. And then question 5, elastic deformation means that it will return to its original shape. Yeah. And the bit about the method we went through in detail. And then the calculations from the graph and what it means. And that is the end of this video. I don't know how long it's taken. Hopefully it's recorded properly. So I'm going to upload it to the YouTube channel. So this is for you to be able to go through it in your own time. And please give us give my video a like. Share it with any friends who are doing GCSE who might find it useful. These are excellent for year 11 students as well, doing revision. I know my year 11 class are going to get a big test this term to help them prepare for their mocks in January, and it'll be units 1 to 6 in the practice test, which is coming in November. Okay, so thanks for watching. Make sure you subscribe if you haven't done so already, so you get notified when future videos are ready. For students doing year 11, there's also a lot of my PowerPoints with me talking over, especially for units 1 and 2, because I know that you do need to revise that. I haven't finished all of unit 2 and I may have missed out the Hooke's law for Unit 1, and I haven't started on Unit 3 yet. I will try to add more videos over the coming weeks. Okay, thanks for watching again. Bye for now.